favorite friends. This is Miss Berger.
And this is Mr. Lamb. And we're here today to teach you about scientific notation.
Well, specifically comparing and ordering scientific notation, since we already know how to do it. So, your learning target is that you can order and compare numbers written in scientific notation.
Okay, so a couple of things we're just going to go over real quick, just kind of as a little refresher for scientific notation. You know, we always write it as, you know, here's our main number in the beginning, 3.9. We always have one number to the left of the decimal point.
Just one. Oops.
Oh, go back.
Sorry.
And then obviously, you know, our exponents tell you how many, you know, how many powers of 10 we're going to use with it. But the thing that we're going to really concentrate on today, because of ordering and comparing, are these exponents first. And if you notice the way these are lined up, you have the -1, the 2, and the 4. Well, Miss Berger, if these are both 2's, why is one in front of the other one?
Well, funny you ask. So, the key to ordering numbers written in scientific notation is to first look at the exponent and place them in order. But if the exponent is the same, you look at the base number. And
there we go.
This one was going in ascending, least to greatest, the 4.2 is smaller than the 5 and 500.
So right here where it says steps 1 and 2, so you order the exponents first, and the coefficients, or the number that's in front of the multiplication symbol, we order them second. So if they have the same exponent, that's what you're looking at to separate them out.
You're looking at that big base kind of number.
Why don't we do a couple? Because I think that would make it more obvious.
That would make it more obvious. Let's do a couple. You need a pen, Mr. Lamb.
I do.
All right, so let's say we have...
I'm going to grab a pen.
We're going to order...
Let's start out with 2 that are the same coefficients.
Okay.
I mean, sorry, the same exponents. That's what I meant.
Because we're going to
compare first.
I see what you're saying. So let's do 3.2 times 10 to the negative, to the positive 3. We'll stick with positives first.
Yes.
Is what to like 5.06 times 10 to that positive 3.
So the first thing we're going to do is look at 2 of them that have the same exponent.
Right.
So it says first, order the exponent. Well, we know they're the same exponent.
They're the same.
So then, if the exponents are the same, we're just going to look at the coefficient, and we're going to use it to figure out which one's bigger, which one's smaller. And since this wants us to compare them, we know we use less than symbols. We use greater than symbols to compare. Or if by chance you end up with something that is, we also use equal symbols.
That's true. And so I know, because I'm so smart, that 3 is less than 5, so that alligator is going to face the bigger number. It's an alligator.
She likes the teeth of the alligator. 3.2, less than 5. You're fine.
You're good. We got it. Do
Okay.
we want to do another one?
Yeah, but let's do one where the exponents are different.
Okay, I got it.
Okay, well, I always like you to write because I write so sloppily.
Yes, we know. So if we had 8.15 times 10 to the 4 is what to like 8.15 times 10 to the 6.
Ooh, that's a good one because look, the coefficients are the same. Somebody might look at this and go, ooh, I bet you this is one of those times we use equal.
But no.
Now, because what do you do first? First, you look at the exponent.
So we have a 4 and
we have a 6.
And I know, because I'm so smart, that 4 is
less than
6. And you can make this one like Pac-Man. Remember, the Pac-Man always faces the bigger number. Should we do a negative?
Yeah, let's do a negative.
All right, because remember, with negatives, it's backwards land.
That's right, it is.
So if I have,
I'm glad we're doing a negative because they can be really confusing.
Yeah. Let's do times 10 to the negative 2.
Excellent.
Is what to 5.1 times 10 to the negative 5.
Ooh, I like that.
Yeah.
So, again, we're going to look at the exponent first. This is a -2, and this is a -5. Now, let's say you get confused a little bit. You go, gosh, I'm not really sure, because these are exponents, which to go. So you can always do this. You could always write 4.05, and we know when we have a negative exponent which way the decimal point moves. It moves this way once,
To the left,
twice.
like Beyonce.
Okay, so that would be 0.0405.
Yeah.
Well, this one, we have 5.1.
You kind of lost me.
Oops, sorry. We have 5.1, and we're going to move it how many times? We're going to move this one 5
times to the left, to the left, to
One,
the left, to the left, to the
2,
left.
3, 4, 5. Wow.
Yeah.
Oh my goodness, you talk about a small number?
That's little.
Yeah, 0.000051 and 0.04. Oh,
Wow.
this one's got to be bigger.
Right. So yeah, if you think back to integers and we were talking about negative numbers, remember on the negative side it's backwards. The closer you are to 0, the bigger you actually are. So if we just looked at the integers, right, those exponents, here's -1, here's -2, -3, -4, here's -5.
So this one
is closer, which makes it bigger, which means the alligator wants to eat that bigger number.
That's right. And so remember, we can still just look at the exponent as long as we can remember that when we talk negatives, that the smaller number is actually the larger
Number. But only on the negative side.
Yes, right, because that's opposite land.
Opposite sides. Alright, so
Okay.
let's compare, or no, sorry, we just compared. Duh.
So we're going to order now.
Okay, I'm going to come up with some and then he's going to do it.
Okay, I like that.
Alright, you stay over there, Mr. Lamb.
I'll just stay over here and I won't even look.
Stay in your lane. I'm not even going to say them out loud.
Yep, not even going to look, so I'm going to show you how fast you can do this. As long as she doesn't mess me up. Ooh,
Hey.
I looked, I'm sorry. It's not that I wanted to cheat, it's that I'm bored.
Calm yourself.
You good?
No.
Okay. She's still working on these.
Boom, I have 4.
That's why she writes so neat, because it takes a long time.
That's right.
Okay, so first thing, I'm going to use this rule because I see they're all different. Okay, so since she didn't tell me which order she wants me to put them in.
I want you to go in ascending.
Ooh.
What does it mean to ascend?
That means to go from low to high. Like when you're on an airplane, you ascend up to the sky. So we're going to start with this one. So this is the smallest, right? So we're going to rewrite it over here as 3.12 times. You guys got to remember that that's a multiplication symbol. 10 to the second power. And we know that that's going to be less than. Now I'm looking and I go, there's my next smallest one. Would you write that for me, Mrs. Berger? Otherwise I'm going to run out of space.
4.3 times 10 to the 4 is
Which
less
is,
than.
I look at these two and I have a 7, so I know that's going to be less than a 9. So would you write that for me again?
Sure.
Because you write so much better.
2.05 times 10 to the 7.
And then of course, obviously, that has to be the biggest number. Man, I'm glad I don't have to write that with all those zeros.
I know.
Scientific notation is cool because that'd be a lot. That'd be like 8 zeros
I
behind
know.
that
That's
3.
what I need in my bank account.
That's what we all
Yeah.
do in our bank
So
account.
remember, check out those exponents, put the exponents in order, and if they are the same, then you look at the coefficient.
Yep.
But I think you got it.
I think you got it. And if you don't, that's okay. Go ahead. Because we always have another one you can look at.
True.
So if you're confused, go ahead and look at that other one. I think you got it because you're really smart.
You're so smart.
But if you don't,